Welcome to the Honda Civic S40 Transmission Rebuild Guide. This guide will walk you through the complete teardown and rebuild of this transmission. Note that this is the S40 B000 transmission from an EX Civic. You may have the A000 if you have a different sub-model of Civic. Keep this in mind while ordering parts. First, be sure to wear the proper safety and protective equipment, and be sure to read and understand all proper procedures for each tool used. Now we will go over the tools. The tools used in this guide include sockets 10, 12, 19, 20, 32, 8mm hex, 1 inch, 1/2 inch to 3/8 inch adapter. Wrenches 10, 12, and 19mm. Ratchets 3/8 inch and 1/2 inch. Extensions 3/8 inch, both 6 inch and 2 to 3 inches. Screwdrivers 2 flathead screwdrivers. Other tools include pry bar, needle nose pliers, snap ring pliers, pilot bearing puller, slide hammer, bearing splitter, 3-jaw puller, shop press, feeler gauge set, Dremel tool with cut-off wheel, mouth or mask breather, safety goggles, mechanic gloves, heat gun, rubber mallet, impact wrench, digital calipers, straight edge, vice grips, bearing press plates, torque wrench, PVC pipe adapter, dial indicator, Honda main shaft holder. To prevent excessive leaking of internal residual transmission fluid, stuff a paper towel, or napkin, into the axle holes. Insert the 8mm hex socket into the interlock guide bolt and unscrew it. Stuff a paper towel inside the interlock guide bolt hole, to prevent residual fluid from leaking out of the transmission. Remove the countershaft snap ring bolt by using the square drive of a 3/8 inch ratchet. Remove the set screws. Each set screw will have a ball bearing and a spring. Tip the transmission to remove the ball bearings inside each pathway. Remove the housing bolts in a cross pattern as shown in the image. Use a pry bar to pry on this point, just enough to crack the seal. Use a pry bar to pry on this point, just enough to crack the seal as well. Insert 2 smooth-ended flathead screwdrivers between the 2 halves, at these points on the transmission. Stop when you feel resistance. Insert the needle nose or snap ring pliers at the point of the 2 dots, and spread the snap ring while prying on the rear end pry bar point. Prying on the housing while spreading the snap ring will allow the housing to separate from the counter shaft bearing. Once the bearing is released from the snap ring, lift the housing from the transmission. If the top main shaft bearing stays inside the case, as shown what happened here, the top of the transmission housing can be heated and tapped with a rubber mallet to release the bearing. Remove the oil guide snap ring, or thrust shim, the oil guide plate and the oil guide feeder. Remove the reverse shift holder by removing the 2 bolts with a 10mm wrench. Remove the reverse gear and shaft. Note the orientation of the gear and shaft for reinstallation. Remove the shift arm, B, bolt. You may have to move the shift shaft to orient the bolt to the accessible angle shown here. Remove the spring washer. Remove the gear and shaft sets. You may have to wiggle the gear sets while pulling to successfully remove them. Work the 2 shafts out. After working them partially out, grab the counter shaft at the bottom and work it up, while turning it slightly, side to side. When the shaft lifts up, the shift forks may fall out, as shown in this video. If you want to look cool while doing this, wear socks with sandals, as demonstrated here. Remember, there is a flat washer and a spring washer on the main shaft. The spring washer bulge faces and rides against the input shaft bearing, and the flat washer sits on top of that. Next, remove the differential assembly. While pulling straight up, lightly work it side to side. Now we will remove the axle oil seal on the bell housing. Take a flat screwdriver along the inner metal ring of the seal and strike it with an impact device. Do the same for the other oil seal. Note the differential thrust shim inside of the bell housing. Now it is time to remove the shift shaft and attachments. First, remove the set ball spring bolt. Note that this bolt has a spring and a ball bearing that will be retrieved shortly. Next, remove the shift arm, bolt and spring washer. Tip the transmission to retrieve the set spring bolt ball bearing. Slide the shift shaft rod out of its channel. Remove the shift arm, from the housing. Next, we will remove the shift arm, bolt, and the shift arm shaft plug. For those without an impact gun, a close-ended wrench and a hammer will do the trick. This makes removing the bolt easier because the shift arm will want to move while loosening the bolt. Remember to keep the spring washer with the bolt as it is removed. Next, we will remove the shift rod assembly. This bolt can be very tight. An impact gun is the easiest way, but the method for removing the last bolt can also be applied here. Once the bolt is removed, the first gear tension spring will come out as well. Next, we will remove the shift arm rod. Note, there is a ball bearing under spring tension under this shift rod. Cover this area while the rod is being removed. Take note that there is a collar inside of the channel that housed the spring and ball bearing. Do not lose this during cleaning of the housing. Remove the shift arm, piece, and then remove the interlock and shift arm, piece. Next, we will remove the reverse select retainer and spring from the transmission case. Next, remove the two 10mm bolts from the reverse lock cam, then remove the lock cam assembly. Next, we will remove the case bearings. First, remove the input shaft bearing with a pilot bearing remover and a slide hammer. Insert the tool and turn it to expand the removal arms, snugly against the bearing. Once the arms are snug against the inside of the bearing, use the slide hammer to pull up. Remember to hold the transmission case down while you do this. Now we will remove the counter shaft bearing. As with the last bearing, insert the pilot bearing remover, turn it to expand the arm snugly against the bearing, and pull up on the slide hammer. Remember to secure the transmission case as you pull up. Remove the countershaft oil guide plate. Next, we will remove the input shaft seal. Use a cushion to make sure you do not dent the surface with your pry tool. Make sure not to scrape the side of the transmission seal surface with the pry tool. Remove the main shaft bearing. The Honda manual calls for a bearing puller, but many times, you can take this bearing off by hand. If you cannot get this off by hand, one of these methods can be used: a bearing splitter with a press, a bearing splitter kit, or a 3-jaw standalone puller. Next, we will press off the 4th and 5th gear assemblies. Depending on your press setup, you may need to have supports against the 4th gear to press against, as shown here. Make sure to catch the shaft since it will fall as the gears are released. Next, press off the 3rd gear assembly. Use the press plates to support the 3rd gear while pressing off the shaft. Again, make sure to catch the shaft as it will fall when the supported gear is released. An alternative way to take apart the main shaft is to use a rubber mallet and a small socket. First, put the small socket inside the bearing race, against the main shaft, then tap against it. This will release the bearing. Next, hold the 5th gear hub and tap the main shaft to release it. Set the hub aside, then take off the 5th gear synchro and synchro ring. Remove the 5th gear, and the 5th gear needle bearing, along with the spacer collar that the needle bearings ride against. Remove the 4th gear, and the 4th gear needle bearing. Remove the 4th gear synchro and synchro ring. Remove the 3rd and 4th gear synchro slider. Remove the 3rd and 4th gear synchro hub by holding below the hub and tap the main shaft to release the hub. Remove the 3rd gear needle bearing. This image shows the list of parts that were pressed off of the main shaft. Next, we will disassemble the counter shaft. We will start by removing the 32mm nut. Before removing the nut, we will need to remove the indentation made on the nut lip. We used a needle nose pliers to take out as much of the indentation as possible. Be careful not to pull too hard, as this may break the tip of the pliers. Next, we will be using an electric impact gun, with a 32mm impact rated socket. The nut should come off very quickly. Remove the washer on top of the bearing. Next we will press off the counter shaft gears. Use a bearing separator to support the top 2 gears as shown here. Make sure the press is square with the counter shaft, then press off the shaft to the point of the top bearing. Release the press and remove the top bearing. Make sure that the shaft is still square with the press, then continue to press off the shaft. Make sure to always be ready to catch the shaft since it will fall when the gears and bearing are released. An alternative way to remove the top bearings will be shown here. Use the bearing separator tool to support the first bearing on the counter shaft. If your press bottom support is not wide enough to fit the whole shaft, the press plates can be used to raise the shaft assembly, as shown here. Next, use the bearing separator tool to support the second bearing on the counter shaft. As with the main shaft, Make sure to catch the counter shaft since it will fall when the supported bearing is released. We will now remove the rest of the shaft. It will not take much to release the gear sets from the shaft. Support the first gear with press plates. Hold the shaft so it will not fall when it is released. Pictured here are the counter shaft components that were pressed off of the shaft. Next, we will remove the differential bearings from the differential. First, we will remove the bearing from the non-speed gear side with a 3-jaw puller. The center of the differential shafts are hollow, so the puller will need support. We used a 1-inch socket with a 1/2 inch to 3/8 inch adapter inside of the socket. Removing the speed gear side of the differential is a bit more tricky. The speed gear blocks most 3-jaw pullers, so a bit of grinding is needed. Some have ground down the jaws on their puller to fit between the bearing and speed gear. Our 3-jaw puller was rented from an auto parts store, so this was not an option. We marked the bearing where our puller would grab onto the gear. We then used a Dremel tool with a cut-off wheel to grind away part of the bearing, so the puller could grab onto the bearing. We measured about 1/4 inch to be ground away at each spot. Be sure to not cut into the plastic speed gear. As with the first differential bearing, we will use the 1-inch socket, adapter, and 3-jaw puller to remove the bearing. Next, we will inspect the synchro to gear hub clearances. Honda lists the standard clearances to be 0.73 to 1.18 mm. The service limit is 0.4 mm. If the clearance is below the service clearance, you should replace the synchro ring and the synchro cone. The service manual calls to put gear oil on the hub and synchro. Turn the synchro until it grabs the hub and it does not turn anymore. Then measure the clearance with a feeler gauge set at all points. Do this for all gear sets. Inspect the sliders. Make sure that the teeth are sharp and not rounded off. If the teeth are worn and are not sharp, the slider for that gear should be replaced. After measuring the synchro clearances and the slider teeth, be sure to put the parts back in order so reassembly is easier. Do this for both the counter shaft and the main shaft. Now, we will remove the shift shaft oil seal. Now we will measure the shift fork clearances. The common problem on this transmission is that the third gear shift fork is worn, causing shifting problems. Measure the fork thickness within the wear pattern. The factory manual's limit for thickness is to have at least 7.4 mm. If the thickness is less than 7.4, replace the shift fork. First, we will remove the 5th gear shift fork. This needs to be separated from the 3rd gear shift fork. We need to have a base that will support the shift fork while the pin is being pressed out. A brake drum is shown here. A punch is needed to drive out the pin. Next we will remove the pins from the third gear shift fork, so that we can remove the hardware. We will use the brake drum to support the shift fork while the pins are pressed out. Next, we will install the hardware onto the new third gear shaft. If you have an out-of-limit measurement on a different fork, you may not need to go this far. Now we will install the hardware onto the third gear shift fork. It is recommended to use a new shift shaft pin. Use a punch to make sure the pin is flush on both sides. Before the fifth gear shift fork is installed, make sure to rotate the hardware on the third shift fork, as shown here. After the fifth gear shift fork is installed, the third gear shift fork hardware cannot be rotated into the proper place. The fifth gear shift fork and its hardware will now be installed. A new pin is recommended for the installation. Now that everything from the transmission has been disassembled, clean the two halves thoroughly. One option is to use a pressure washer. Others include using degreasers. Make sure to clean off all degreasing solutions before reassembling the transmission. Now, we will install the main shaft oil seal and the main shaft bearing. Make sure to place the oil seal with the solid face facing down. The side with the flexible lip and spring should be facing up. Use a seal driver plate that contacts the rigid outside diameter of the seal. Tap into place. Make sure that the seal reaches the bottom of its bore. The evenness of the seal can be checked with a depth caliper set. Check multiple points around the circumference of the seal against the machine surface. Next, we will install the main shaft bearing. Make sure to install the bearing with the letters facing upwards, for easy identification if it ever needs to be replaced in the future. Use a bearing press plate to tap the bearing into place. Make sure to use a bearing press plate that contacts and applies pressure only to the outside of the bearing. It is also important to make sure the bearing goes in straight. If the bearing is difficult to get all the way into the bore, a shop press can be used to finish the job. Stop when you feel resistance. Spin the inner race to make sure it turns freely. Next we will install the counter shaft oil guide plate and the counter shaft bearing. Install the guide plate with the spout facing up. Set the bearing with the identification letters facing up. Use a bearing press plate that will press on the outside race of the bearing. Make sure to tap the bearing in straight. As with the last bearing, if it will not tap in all the way, a shop press can be used to press the bearing in the rest of the way. One extra step that can be taken is to stake the counter shaft bearing with a center punch. These are known to walk themselves out of their bore, causing second gear shifting problems, so staking the bearing can help keep it in its place. Use a punch to stake the bearing in several places. This process is not in the Honda service manual, but it is what many community builders do to their transmissions. Next, we will install the reverse lock cam. First, insert the lock cam into the housing, then install the bolts. Using a torque wrench, tighten these 10 mm bolts to 11 foot-pounds. Next, we will install the reverse select spring and the reverse select retainer. Compress the spring into the retainer, then press it into the transmission housing. Now we will install the collar and spring for the secondary shift shaft. Place the spring inside the collar. Then, drop the assembly inside of the transmission housing. Slide the shift shaft into the transmission housing. Make sure to point the large notch down toward the spring and collar we installed earlier. Assemble the interlock before sliding the shift shaft in all the way. The shaft will go through the interlock assembly. Push the shift shaft through the interlock assembly. Stop before you get past the spring and collar within the transmission housing. drop the ball bearing on top of the spring and collar. Use a device, like a chopstick, to depress the ball bearing into the collar while sliding the rest of the shift shaft into the housing, so that the ball bearing rests underneath the shift shaft. Next, install the shift piece. This piece slides over the shift shaft. When you push the shift shaft all the way into the transmission, you will feel a prominent click. Install the shift shaft oil seal. Use a 20mm socket to tap the oil seal in. Lubricate the inside of the shift shaft seal with transmission fluid. Clean the shift shaft. Slide the shift shaft into the seal. Make sure that the 3 notches face up. Now we will install the shift shaft piece. This links the 2 shift shafts together. Install the set ball spring bolt, the spring, and the ball bearing. First install the ball bearing. Then install the spring. Finally, install the bolt. Install the bolts for the shift shaft link. Make sure that the convex side of the spring washer faces the head of the bolt. Torque the 2 black shift piece bolts to 23 foot-pounds, or 31 Newton-meters. Torque the spring bolt to 16 foot-pounds, or 22 Newton-meters. Before assembling the shafts, clean the oil ports, and inside the shafts. Many times, they are blocked by fluid sediment. Now we will move on to build the main shaft. First, the 3rd gear needle bearing will be installed. Be sure to clean all parts and cover in transmission fluid before assembly. For larger parts, such as this gear cone, have a small bath of transmission fluid to set the part inside. Have a second container for the excess fluid to drain inside. The 3rd gear will be installed over the needle bearing. The 3rd gear synchro spring will need to be clipped onto the synchro, then slid onto the gear cone. Install the hub onto the main shaft. Make sure to position this so that the U-shape faces up. The slider key will slide into this slot when it is installed in the next step. Make sure that the synchro fits properly into the hub's notch. You may have to use a stable surface to press against to get the hub all the way onto the main shaft. Install the gear slider. Make sure that the notch in the slider is facing up when it is installed. This will slide into the hub's notch. Certain teeth on the slider are keyed so that the slider will be installed in the correct position. Slide it down onto the 3rd gear so that it clicks. Next, install the synchro and spring set. Then install the gear cone. Install the needle bearing, then the spacer collar. Install the 5th gear needle bearing onto the spacer collar. Install the 5th gear over the needle bearing. Make sure that it spins freely. Next, install the 5th gear synchron spring assembly. Install the 5th gear hub. Make sure to install the hub with the 3 notches facing up. You will need to use a tool to tap the hub onto the main shaft, as it is a snug fit. Make sure that the synchro notch is within the hub's notch area. Install the 5th gear slider onto the hub. Make sure that the angle teeth of the slider point toward the synchro when installing. As with the other parts, cover the top bearing in transmission fluid, then let it drain. Install the top bearing. Make sure to install the bearing with the stamped letters facing up. You will need to tap the bearing the rest of the way onto the main shaft. Install the first needle bearing onto the counter shaft. Install the friction dampener into the first gear. Make sure to dip this in transmission fluid to make installation easier. Slide the gear over the needle bearing. Slide the synchron spring assembly onto the first gear cone. Install the gear hub. Make sure that the side of the hub that says up is installed facing up. Another important thing in this step to follow is to align the teeth from the friction dampener and the holes on the bottom side of the hub. These must line up so that the dampener can grab onto the hub. Be sure to also align the notch in the hub with the corresponding spot on the synchro. To test that the hub and the friction dampener is installed correctly, rotate the first gear. It should turn freely with a bit of drag. Install the slider. Make sure that the teeth on the outside of the gear is facing up. Install the friction dampener onto the second gear. Make sure this has been coated in transmission fluid. Install the synchron spring assembly onto the gear. Install the gear and synchro assembly onto the counter shaft. Make sure to align the teeth on the friction dampener to the notches on the hub, and that the notch on the hub aligns with the corresponding spot on the synchro. Turn the gear to check for drag, indicating that the friction dampener has been aligned correctly. Install the collar, then install the needle bearing. Again, turn the gear to make sure there is drag, indicating that the friction dampener is correctly aligned. Install the fixed third gear with the gear teeth on the bottom side. Install the fixed fourth gear with the gear teeth on the top side. Tap into place with an adapter if needed. Install the fixed fifth gear with the 3 notches facing up. Tap into place with an adapter if needed. We will now install the countershift bearings. First, install the needle bearing that comes with the cage. Heat it up slowly, not exceeding 210 degrees, with a heat gun. Other heating methods are available. Tap the bearing into place by only contacting its inner race. Coat the bearing's cage in transmission fluid, then install onto the bearing. Install the ball bearing with the notch, which is what the transmission housing clip fits into. Heat the bearing slowly with a heat gun, not to exceed 210 degrees. Make sure the notch on the bearing is at the top. Tap with an adapter, contacting only the inner race. Coat the ball bearings in transmission fluid. Install the spring washer. Make sure that the convex side is pointing up. Then install the countershaft nut. Torque the top nut down to 80 foot-pounds. Loosen the nut to 0. Then tighten the nut again to 80 foot-pounds. Use a punch to stake the top nut. Now we will install the bearings on the differential. As with the countershaft bearings, heat these bearings up slowly, not to exceed 210 degrees. If you tap onto the bearing, only contact the inner race. Use an adapter to contact the inner race, if needed. Make sure that the speedometer gear is installed on this side of the differential before installing the bearing. Install the transmission magnet into the housing. The magnet part will be on top. We will now measure the clearance to determine the correct main shaft thrust shim. If none of the gears were changed on the main shaft, this may not need to be done. To start, remove the thrust shim from the housing. Install the top bearing on the main shaft. Insert the main shaft into the housing, and tap with a mallet to ensure it is seated. Put the thrust washer on the end of the main shaft. Lay a straight edge across multiple points on the transmission housing. Use a depth gauge on top of the straight edge and measure down to the thrust washer. Take that number, take away the length of the straight edge at the point that you used to measure, and that will give you the clearance between the thrust washer and the edge of the transmission housing. Take an average of the multiple points that you checked. Use a depth gauge over the input shaft bearing inner race. Do this at multiple points, and take an average of the numbers. To calculate the correct shim thickness, take the averaged clearance between the thrust washer and the edge of the transmission housing, which is letter B in the formula, add the averaged clearance between the input shaft bearing and the clutch housing, which is letter C in the formula, take away 0.95 mm for the thickness of the spring washer. An example is given on the screen, taken from the Honda service manual. Install the oil guide into the transmission housing. Install the oil guide plate over the oil guide. Install the main shaft thrust shim into the housing over the oil guide plate. Also, install a new countershaft bearing snap ring into the housing. Now we will install the main shaft and countershaft into the transmission. First, cover the splines of the main shaft with tape to protect the input shaft bearing seal. Install the shift forks onto the main shaft and countershaft. Make sure that the shift guide pieces line up side by side. Before installing the shaft assembly, lift the transmission casing so the main shaft has room while being installed. Install the differential into its place into the casing. Place the input shaft bearing spring washer onto the input shaft bearing. Make sure the convex side is facing toward the bearing. Then, install the main shaft washer on top of the spring washer. Now we will install the shaft and fork assembly. Make sure that the countershaft fits squarely into the countershaft bearing, and that the shift shafts fit into their corresponding holes. Make sure that the interlock is able to fit into the shift fork. You may have to move a shift shaft to make sure it fits. If not done already, install the main shaft top bearing. Install the interlock bolt and spring washer so that it locks to the shift shaft. Make sure that the convex side of the spring faces toward the head of the bolt. Torque this bolt to 23 foot-pounds, or 31 Newton-meters. Install the plug bolt. Coat the bolt in sealant. Install the shift spring, then install the bolt. Torque the bolt down to 40 foot-pounds. Install the reverse gear shaft and gear. Make sure to orient the gear so that the teeth are on the top side. Install the reverse shift holder. Note that the points on the shift shafts fit into the shift holder. Install the reverse shift holder bolts. Torque these bolts to 11 foot-pounds. Now we will add Honda bond to the sealing edge of the transmission. Make sure that the surface of both sides of the sealing edge are perfectly clean before applying the sealant. Make sure the layer is very thin. The sealing edges are well machined, so not much sealant is needed. Install the transmission dowel pins. Fit the transmission housing cover over the transmission base. The mating surface of this also needs to be perfectly clean. Make sure that the differential shim is installed in the housing. This clearance will need to be measured after installation. After the housing seats, spread the two halves of the countershaft bearing snap ring so that it will fit around the bearing and into the notch. If the snap ring doesn't fully seat, as shown here, turn the transmission upside down so that the weight of the shaft will shift and cause the clip to fall into place. Do this only after all case bolts are installed. Install the transmission case bolts. First, install the bolts finger tight, then torque down to 20 foot-pounds. When tightening the bolts, do so in a crisscross pattern, as shown here. Make sure to install the transmission mounting brackets, as shown here, before tightening the bolts. Now we will install the interlock guide bolt. First, coat the bolt with sealant. We used Honda Bond HT. Before installing the bolt, make sure that the interlock is lined up with the hole. When positioned correctly, the interlock will make two parallel lines, equal space on each side. If this is not the case, line it up correctly by using the shifter. If the bolt is installed without this being aligned, the interlock will be bent and will lock your transmission out of using certain gears. Install the guide bolt. If you feel any type of resistance, stop and find out what is causing this. If it is a misaligned interlock, use the shifter to realign the interlock. We will now install the bolt over the countershaft snap ring. Coat the bolt in sealant. Again, we used Honda Bond HT. Torque the bolt down to 18 foot-pounds. Now we will install the set spring bolts. This includes the bolt, a sealing washer, the spring, and a ball bearing. Torque these down to 16 foot-pounds. Install the transmission hanger. Torque these to 20 foot-pounds. Now it's time to run through the gears to make sure the transmission was put together correctly. Use a long shaft screwdriver to poke through the shifter shaft. To get into first gear, turn the shifter counterclockwise and pull out. Turn the main shaft. The shaft should turn easily. For second gear, turn the shifter counterclockwise and push in. The axle should turn a little faster. For third gear, pull up to get into neutral, then pull out. For fourth gear, press the shift shaft in all the way. For fifth gear, pull up into neutral, then turn the shift shaft clockwise, and pull out. The differential should be turning the fastest out of all the gears. Shift into reverse by turning the shift shaft in a clockwise position, then pressing in all the way. When shifting into neutral, the differential may still rotate as if it is in gear because of the viscosity of the transmission oil creating friction, as shown here. The next clearance to test is the differential bearing clearance against the differential housing shim. Honda calls for a clearance of 0 to 0.10 mm, or 0 to 0.004 inches. Make sure that the measurement is done between the shim and the bearing. Before the measurement is taken, tap the differential down to make sure it is seated. Install the axle oil seals. Use a device to tap the edge of the oil seal into the transmission housing. Tap the oil seal into the housing until the edge of the seal is even with the edge of the housing. Note that the axle oil seals are different on each side of the transmission. We will now confirm the correct clearance for the main shaft. We will do this by using a dial indicator to measure the movement of the main shaft while tension is applied to it. Tension will be applied by the Honda Special Tool, part number 07GAJPG20110. First, clamp a steel base to the transmission housing. This will give the dial indicator base something magnetic to attach to. Next, attach the Honda tool to the main shaft, and use something for the bolt to press against. We used a wrench. Zero out the dial indicator against the main shaft. Start turning the bolt until it stops moving. After the needle stops moving, do not turn more than 60 degrees, otherwise you risk causing damage to the transmission. Honda calls for a clearance of 0.004 to 0.007 inches. This measurement was just below 0.007, so it is within spec. If it is not within spec, choose a different main shaft thrust shim and install it into the transmission. Install the vehicle speed sensor. Insert the sensor into the hole, then tighten down the bolt. Install the backup light switch with a new washer. Screw the switch into its hole, then tighten down to 18 foot-pounds. This guide showed the complete teardown and rebuild of this Honda Civic S40 B000 transmission. Parts of this teardown you may not need. If only one part of the transmission is bad, only use the parts that you do need. Remember, if you have the A000 stamped transmission, slightly different bearings will come in your kit. Refer to your Honda factory service manual to ensure the proper steps for your transmission are followed.